Assalamualaikum warahmatullahi wabarakatuh. My name is Daniel Afiq bin Azlan, metric number 170566 from Group DA. And our group will be presenting our Chemistry 2 Popbl. So, without further ado, let's continue with the task.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nabila Syahada binti Muhammad Kamal, metric number 171924. The Popbl process is the industrial process for the manufacture of ammonia from hydrogen and nitrogen. Hydrogen is obtained from the reaction of methane and steam, producing carbon monoxide as a byproduct. The hydrogen produced from this reaction also reacts with oxygen from air, producing water. These gases are then compressed and delivered to the reactor where ammonia is produced. These gases are then cooled down and ammonia is liquefied, ready to be tapped off. Unused hydrogen and nitrogen are recycled back to the reactor. Let's revisit the reaction again. Note that this is a reversible reaction and that the forward reaction is exothermic. The Popbl process uses Le Chatelier's principle to maximize ammonia production while keeping operating and production costs in mind. Le Chatelier's principle tells us that increasing pressure will favor the site with fewer moves. For our case, the production of ammonia, it will make sense to conduct the reaction at a very high pressure. But we must also remember that it is expensive to build and operate a plant that can withstand with such high pressure. Therefore, a compromise pressure of 200 atmosphere is used. Keeping Le Chatelier's principle in mind, what do you think is the best temperature condition to maximize ammonia production? Since the forward reaction is exothermic, it would make sense to conduct this reaction at a low temperature. The compromise temperature is 400 to 450 degrees Celsius, which is not exactly low but not too high. If a low temperature were used, the rate of reaction would be very slow to the exothermic reaction would be favored. It would also take a long time for the equilibrium to be reached, so a compromise temperature of 400 to 450 degrees Celsius ensures that the reaction proceed with sufficient yield. The yield of this process is 10 to 20%. Remember from the introduction that unused gases are recycled, so no reactants are wasted. As well as an ion catalyst is used in this process, the presence of the catalyst does not affect the position of equilibrium, but increase the rate at which equilibrium is reached. What is Oswald process? It's using ammonia, a colorless alkaline gas with pungent which highly soluble in water to manufacture the nitric acid. There are three steps in the process flow. The first step is ammonia oxidation. Ammonia and oxygen enter the catalytic converter, which contains platinum gas as catalyst, and is converted into nitric acid, nitric oxide and water. It operated at high pressure and high temperature, which 700 to 800 degrees Celsius. Step 2. Nitric oxide oxidation. Nitric oxide from ammonia oxidation is very hot. It is then passed through a cooling tower, where its temperature is cooled to 150 degrees Celsius. It is transferred to the oxidation chamber and oxidized to nitrogen dioxide at 50 degrees Celsius. And the last step is step 3, absorption of nitrogen dioxide. Nitrogen dioxide from secondary oxidation is then under the absorption chamber. Water is showered over it, and diluted nitric acid is obtained by absorption. It is then recycled and combined with water and oxygen to produce a high concentration of nitric acid.
Bismillahirrahmanirrahim. My name is Zulkarnain bin Mak Sabri, metric number 173409. I am from Group DA, and now I will explain about our issue, which is how to improve the condition of the river Tombak. So, the method that can help to improve the condition of the river is liming process. The liming process means a process to add high alkalinity compounds into the river or lakes. Usually the compound used is calcium carbonate or calcium hydroxide or calcium oxide. So the process is quite simple, which is to add the compounds which usually in form of solids to being added into the river. So theoretically the process is neutralization process. For example, this compound used is calcium carbonate. So calcium carbonate be reacted with nitric acid will produce water. So that's the basics of liming process.
This liming process is actually quite simple, in which a load of granulated limestone is usually brought by boat to the river, and the boat will disperse and distribute the limestone equally throughout the river, and at the end all the granulated limestone will cover the whole area of the river surface. This limestone will neutralize the acidity of the river water within a few days. However, this method is temporary and also expensive. If in the future, after the process of liming, the factory decides to dispose more nitric acid into the river, the acidity of the river water will increase again, which means the factory itself has to take other alternatives in order to dispose the nitric acid residue somewhere else instead of into the river.
The next problem is there any other way for the company to dispose the nitric acid rather than disposing it to the river? There is another way. So the first thing they have to do is they have to keep the nitric acid safely first, and then to neutralize the nitric acid they have to add sodium bicarbonate to the nitric acid. So they will have a neutralized mixture of nitric acid and sodium bicarbonate. So the addition of sodium bicarbonate is not enough. They have to add another filtered water to the mixture of nitric acid and sodium bicarbonate to make sure that the dilution is perfectly diluted. And then they have to get sure that the water they use is filtered water, not mineral water, because mineral water have other contaminants that can react with the mixture. So we don't want that thing to happen. So we use filtered water instead of mineral water. So this will match the mixture of the nitric acid and the sodium bicarbonate. We add another with diluted with filtered water.
So the neutralized waste from this procedure will be labeled as hazardous waste and will be sent to the right company that can dispose this kind of waste. The disposal must meet a certain law and protocol from the government, Ministry of Natural Resources and Environment (MER). It must be enacted by Environmental Protection Society Malaysia and Department of Environment.
Now we proceed to the next learning issue, which is how to increase the efficiency of acid nitric production. Before that, my name is Muhammad Luqman Hakim bin Rusli and my metric number is 171074. For the first method, we will use the method of extended the absorption and selective catalytic reproduction. This is used to increase the reduction of nitric acid. First of all, the main concern in this method is how we build our plant. We will need the plant that can handle a high pressure in the production of nitric acid. There are two types of systems that can be installed in the plant. First is the high pressure in a one pressure process, and the second is the dual pressure, which is combined with the SCR technique.
To Brother Luqman just now for his first method on increasing its efficiency. Now my name is Izo Ismail Ibrahim. My metric number is 170872. I'll be explaining on the second method to increase the efficiency of production of nitric acid. As you all may know, nitric acid is a very dilute acid. So to increase its production and by means efficiency, we have to increase its concentration so that the reaction will be continuous and not in equilibrium. According to Le Chatelier's principle, a decrease in temperature favors reaction in forward direction. With that, to prevent the reaction to be in equilibrium state, we must decrease its volume and pressure. This is so that the equilibrium will shift towards the side of the reaction with the last number of moles to help ease the pressure. And that's all from me, I guess.